Let's do another example problem. This time we're not going to be looking at a horizontal projectile, but rather a projectile that is given a velocity in both x and y. So a projectile is launched at 20 degrees above horizontal at 30 meters per second from 10 meters above the ground. What is its range? So again, we're trying to figure out how far did this projectile go. I'm going to start this problem by drawing a picture. And that's because we have lots of things happening, and remember we have to keep our x's and y's separate. So here's my projectile. It says 20 degrees above horizontal. So this angle right here is 20 degrees, and this velocity is 30 meters per second. Now, that's not x or y, that's x and y. That's its total velocity, right? Which means it has a velocity in x, which is 30 cosine 20, and it has a velocity in y, which is 30 sine 20. So by drawing that picture, I instantly get some information. Now the other thing to keep in mind is this thing goes up and comes back down, but it doesn't come back down to the same height. It comes down 10 meters below that because it was launched 10 meters above the ground. So let's take all that information, list it, make sure we label it well, and then we can start solving problems. So I've got x, I've got y. Initial velocity in x is 30 cosine 20. Initial velocity in y is 30 sine 20. Initial position in x, x naught is equal to 0. Initial position in y is equal to 10. Final position in y is 0. Final position in x is what we want to know. Acceleration in y is negative g. Acceleration in x is 0. So we've got our x's and our y's separated. We went ahead and used our trig over here to figure out what those could be. And now it's just back to the same way we solve horizontal projectiles. We've just got this other stuff to deal with, right? And so x equals 1/2 at squared plus v naught t plus x naught. And so x equals 0 plus 30 cosine 20 times t. So again, I need the time in order to figure out how far this is going to go. And so we'll go to the vertical direction for time. So y, actually I'm going to go with delta y, equals 1/2 at squared plus v naught t. Well, delta y is negative 10, right? Because it started 10 meters up and ends at the ground. So negative 10 equals negative 4.9. That's half of negative 9.8 t squared plus 30 sine 20 t. I can add over that 10 and I get 0 equals negative 4.9 t squared plus 30 sine 20 t plus 10, and that's the quadratic. So we run that into the quadratic, negative b plus or minus the square root of b squared minus 4ac all over 2a, and you'll come up with two numbers, right? Because this is going to find the path of a parabola, and this parabola is going to look like this, and it's going to have a displacement of negative 10 at a couple different times, but one of those times will be negative. We don't want the negative time. So we get our time there, and then we plug it in over here, and we have our range.